Okay, let's have a look at functional groups. Functional groups are groups that bind to carbon chains and substitute for hydrogen atoms. So we have the first type of group, which is called an alkyl halide, often shortened to halides. And they're shortened, or they're denoted by an R and an X. So an example would be if we had our methane molecule and we substitute one of the hydrogens for a chlorine. So this molecule we would call chloromethane. We can also have a second type of group called an alkanol, which used to be known as alcohols, and most people know them as alcohols. In this case, we've got a carbon bonded to a hydroxy group or an OH group, and if we look at our methane, we substitute a hydrogen for our hydroxy group. This molecule is called methanol, and it's our simplest alcohol or alkanol. We can also have an alkanal, Al as opposed to Ol, and in this case, to our carbon, and this is a terminal carbon or a carbon at the end of the chain, we have a double bond to an oxygen. So we have a simple molecule. This one here is one carbon bonded to an oxygen, double bond, and to two hydrogens. This one we call methanal. The Al denotes the alkanal. We can also have an alkanone, O-N-E, instead of A-L or O-L. This time our double bonded O is not at a terminal carbon, but an intermediate carbon. And that's an important distinction between alkanals and alkanones. So we've got an example, a methyl group bonded to our carbon, bonded to another methyl group, and this oxygen here is double bonded. Because it's three carbons, we have a propan as our prefix, and it's propanone for our alkanone. Now, so far we've looked at halides, we've looked at oxygen being bonded. We can also get a nitrogen being bonded to the carbon as well. In this case, we have an amine group, which is carbon bonded to nitrogen, and that bonded to two hydrogens, although those hydrogens can also be substituted for a more complex amine. But let's keep it simple for the moment. We have a CH3 group, so it'll be a methane of some type, and we have our amine. So this one is known as methylamine, the methyl group coming off the nitrogen, so methylamine. We can also have an ether group, which going back to our oxygen. This time I've put in two different symbols. I've got an R here which denotes a carbon chain, and an R dash which could be the same carbon chain or it could be a different one. So our ether is one carbon chain, single bonded to an oxygen, single bonded to another carbon chain. So an example, we've got in this case I've made my R and R dash the same thing. So I've got a methyl group and a methyl group, single bonded to an oxygen in the middle. And this one is known as methoxymethane. We can also get slightly more complex molecules. So we can form what's called an alkanoic acid, or what is more commonly known as a carboxylic acid. And in this case, to our terminal carbon, we'll have a double bond to an oxygen and a hydroxy group. So it's a combination of our alkanal and our alkanol to get an alkanoic acid. And we have a CH3C, and it's often written as COOH to denote that we have our alkanoic or carboxylic acid. And in this case we've got, because it's got two carbons, ethanoic acid. And then finally, although there are a lot more molecules, we can have an ester, which is a derivative of an alkanoic acid. So similar structure, except this time we substitute the hydrogen on our hydroxy group for another carbon chain. So we represent that with an R dash. So in this case I've got a CH3, COO. Instead of the H, I've put in another methyl group. So we have what's known as methyl ethanoate.